Hey, Geometry, Lesson 6. It's your first video lesson, so we're going to talk through a few things, and this may be a little bit longer than my goal, but it's because we're going to talk through a few things as we go. So the first slide is always going to have the lesson number and the topic. We're going to be solving for unknown angles, and angles and lines at a point. Really, this video lesson is like a PowerPoint slideshow. It would be me at a whiteboard talking through the lesson. Instead, the whiteboard is on your computer or your iPad, and we're talking through the lesson. So, first of all, when we are solving for unknown angles, I want to do a little bit of background first, what we've been doing for the past 5 lessons. We've talked a lot about congruence. The definition of congruence. So if we have figures that are congruent, that means that they're identical in form. We're going to learn how to solve for unknown angles and diagrams and justify each step or decision in the proofwriting process of unknown angle solutions. So when I say justify, as geometry goes on, we're going to be writing proofs, which are step-by-step reasons for why we do things. That's why we've been really purposeful in our constructions, writing step by step so we can start to learn how to write words in a meaningful way. This topic, it's important to show each step of your work and to list the geometric reason for each step. We'll need this information when we begin to write proofs. Opening exercise. This is called the warm-up. I need you guys to do this on your own. All that means is I'm going to push pause on the video. I need you to push pause too and try to muscle through this warm-up, because if you can muscle through it, you're going to learn more than just watching me perform the task. So push pause, please. Alright, what we see here, first I did my work in red. I know that this is a straight line, and we know that straight lines are 180 degrees. So if I take 180 degrees, which is the whole straight line, and I subtract out 36 degrees, right there, I'm left with 144. I'm looking for this one though. So here in blue, I have another straight line, which is 180 degrees. I subtract out 144 degrees, and I'm left with 36. Cool? Then I worked on this black line here. The line is 180 degrees. I subtract out 121 degrees, and I'm left with 69. Alright, this next one. Okay, push pause. Remember, this is your warm-up. Alright, here we have, I drew a circle. A circle is 360 degrees. I subtracted out 172, and I subtracted out 82, and I'm left with 106 degrees. Okay, what facts about angles did we use? We used a fact about a straight angle is 180 degrees, and a circle equals 360 degrees. Okay, our discussion. 2 angles, angle AOC and angle COB, with a common side OC, are blank. Let's fill that in. I'm going to draw a picture for you guys. This is adjacent. If C belongs to the interior of angle AOB, okay, again, I'm going to draw a picture. Give me a second. The sum of angles on a straight line is 180 degrees. There's a straight line. It's going to give you 2 random angles. Okay, this is called a linear pair. So let me label this with our first sentence. 2 angles, angle AOC and COB, with common side OC. So I have OC. It's a common side because it's shared by 2 angles, AOC and COB. This being our shared side. Okay? So these two are adjacent. If C belongs to the interior of AOB. And here we have AOB is a straight angle, so C belongs to the interior of AOB. The sum of the angles on a straight line is 180 degrees, and two such angles are called a linear pair. It's a very important vocabulary word. Two angles are called supplementary if the sum of their measures is 180 degrees. Two angles are called complementary if the sum of their measures is 90 degrees. Pause there. We're going to tell you that a linear pair is also supplementary. Describing angles as supplementary or complementary refers only to the measures of their angles. The positions of the angles or whether the pair of angles is adjacent to each other is not part of the definition. They do not have to be adjacent to be supplementary or complementary. I can draw two angles like this, and visually we can assume that that would make a straight line at the bottom and they are supplementary. Or I can give you a complementary one that is 90 degrees. In the figure, line segment AD is drawn. Find the measure of angle DCE. So line segment AD is drawn. So AD is a line, therefore, oops, need a pen. AD, the measure of AD, line segment AD is 180 degrees. So we want to find the measure of angle DCE. DCE. So we have to figure it out. The whole thing is 180. I need to subtract out 72, and I need to subtract out this measurement right here. That's a perpendicular symbol, so we know that's 90. So 180 minus 90 is 90, minus 72 is 18 degrees. I only have 18 degrees left over in that 180 degree straight line. The total measure of adjacent angles around a point is, remember we're going with the whole circle here, so we know the total measure of angles around a point is, whoops, erase that, please don't write that down, 360 degrees, because it's a circle. Find the measure of angle HKI. HKI is right here. So we have 360 degrees minus 133 minus 147. 12 minus 4 is 8. 80 degrees. Okay, vertical angles have equal measure. Two angles are vertical if their sides form opposite rays. Let's talk about that for a second. I have this angle right here, angle SRU. If I look at this side right here and this side right here, these are opposite rays. Okay, they start from the middle and they go out. That's ray RS and ray RV. Let's change colors. Coming here, I have ray RU and ray RT. Those are opposite rays. That means this angle and this angle are vertical and therefore equal or congruent. Therefore, we know that angle TRV is also 52 degrees. All right, find the measure of each labeled angle and give a reason for your solution. Okay, first of all, angle A. Okay, it's a linear pair, it's supplementary, so we're going to go with 180 minus 145, 35 degrees. My reason is linear pairs, oops, Spelling is important. Let's do it again. Linear pairs are supplementary. Okay, where's angle B? So check mark, angle B. Here I have another linear pair. So 180 minus 40 is 140. C above. Angle C. So we got angle B. Angle C looks to be vertical from here. So 40 degrees. Let's try to write that better. Vertical angles. Vertical angles are equal. Cool. Angle D looks to be vertical from B. And B is 148. No, 140. Angle B. I have a typo here. That should be 140. I'm not sure what that 8 looks like. And that's also going to be vertical angles. You could also use the linear pairs, our supplementary rule. And angle E. I have a circle here. So 360 minus 146 is 214 minus 117 is 97 degrees. And that is angles at a point. Sum to 360 degrees. Cool. Okay, sorry. Now we have exercises 1 through 5. It's a lot of exercises that you're just going to practice on your own. So we're just going to go through one at a time, and we're going to do a lot of pausing. I want you to try these on your own to see if you can practice them, and you can come in tomorrow with questions. So go ahead and pause. All right, there we go. Check out the answer. Take your time. Make sure you understand it, and then we can move on. Okay, I accidentally cut and pasted the wrong problem here, so I had to hand draw it in. But it's correct on your classwork. We're looking for the measure of angle B. Okay, our solution is, I have a straight angle right here, which is 180 degrees, minus all of the given angles. 17 minus 9, 8. And then subtract 36. 13 minus 6 is 7. So we're at 47 degrees. And our reasoning here is consecutive, adjacent, angles on a line, sum, not sun, sum to 180 degrees. Okay, number 3, go ahead and push pause and solve it. Push pause though. Okay, there you go. I gave 2 reasons. The first reason, I noticed that this right here is a 90 degree angle. Therefore, this right here is also a 90 degree angle. So I just either made those complementary, or I've got the straight line here and consecutive adjacent angles on a line, sum to 180. Okay, go ahead and push pause Note that we're looking for two of the same angles that are equal. So see if you can figure it out. Okay, there you go. We have one more on this set. Whoa, that's a lot of numbers. But we're looking for all of the same G's. So go ahead and push pause. Okay, this one's sort of fun. I have angles around a point, which sum to 360. I have three 91-degree angles, so I went ahead and multiplied 91 times 3. Then I subtracted that from 360 and got 87. My unknown angles are all the same, so I need to divide it into 3 pieces, and I get 29 degrees. Okay, exercises 6 through 12, find the values of x and y and show all your work. So we're adding a little bit of algebra into our geometry. So first you're going to need to solve for the unknown angle sum, like all of the unknown angles together, and then try to solve for x. So let's do this first one together. Okay, this is angles at a point sum to 360. So I have 360 minus 85 minus 35. Hold on. Let me erase this and start over. First, let's add up everything that we see in the angle. So 2x plus 85 plus 35 plus x. What does this equal? Well, it's sum of angles around a point. So 360. Okay, let's collect like terms. 2x plus x is 3x. 85 plus 35, let's see, that's 10, 8, 9, 10, 11, 12, equals 360. Subtract 120 from both sides. Divide both sides by 3. X equals 80. Okay, the instructions say show all your work, which I did. And our reasons are, just like the previous problem, angles at a point equals 360. That's poor handwriting. Okay, next I'm going to push pause. Go ahead and try this one on your own. I have some vertical angles here, but I also have angles around a point. So let's see what you can do. Alright, you're going to have to follow along. This is probably the most challenging problem we've had yet. First of all, let's look at what I circled in red. These are vertical angles. We know that vertical angles are equal. So right here, I set them equal to each other. Let me draw a line here. So we have 2x equals y minus x. 2x equals y minus x. I added x to both sides and got 3x equals y. Stop there. Then in blue, I circled a linear pair. These are supplementary. You add those together and set it equal to 180. 2x plus y plus x equals 180. 2x plus y plus x equals 180. Collect like terms. 2x and x is 3x. I moved the y to the other side of the equal sign, so I have a negative y plus 180. Now I have two equations, and I can solve for them. Alright? So I went ahead and subtracted this equation from the first equation. So we have blue minus red. 3x minus 3x is 0. Negative y minus y is negative 2y plus 180. Move the negative 2y over and divide both sides by 2, and I have y equals 90. So I can put that up here. And then I can plug y equals 90 into one of the original equations. So instead of y, I write 90, divide both sides by 3, x equals 30. Phew! Alright, try this one on your own. Try to do some vertical angles, see what your angles equal. I'll point a few things out. This is a perpendicular sign, which means that this whole angle is perpendicular to This whole angle is perpendicular, and so is this one, but we don't care about that one because there's nothing there. So this is 90 degrees, and that's 90 degrees. Okay, these are vertical angles, so they're equal. And see what you can figure out. I'm going to erase this, though. Okay, go ahead and push pause. Okay, there you go. The first thing I did was brought x degrees over here because these are vertical, and then I know that this is 90 degrees because this line is 180. This one is perpendicular to this one, so this one is 90. I did some math. X plus 4x minus 10 equals 90. Collect like terms, subtract 10 from both sides, and solve it. Okay, go ahead and push pause. Lots going on here. See if you can make any sense of it. But I'm going to push pause first. Go ahead and try. Okay, that one was sort of fun. The first thing I did was saw that this angle and this angle are vertical. And then I have a straight line here, which is 180 degrees. So I took all of the angles in here and added them together and set it equal to 180. X minus 10 plus x minus 11 plus 3x plus 6 equals 180. Gather some like terms and solve for x. X equals 39. Then up here, like, okay, if x equals 39, go ahead and plug it in. 3x plus 6, x equals 39. These are vertical angles, set it equal. 3x plus 6 equals y. Plug in 39 for x and solve. Cool. Fun. Go ahead and check this one out. Okay, see what you can make sense of. When you're trying to gather like terms, see if you can gather terms that are equal, like x's and y's. If this is 90 degrees, that means this is also 90 degrees. This is a vertical angle with this one right here. Those are your hints. Okay, this one's sort of fun too. Okay, first I saw, when I showed you the hints, this angle is vertical with this one. So if I transpose 3/4 x minus 2 up there, I know that if this is 90 degrees, then this equals 90 degrees. So I merely went 3/4 x minus 2 plus 2/5 x equals 90. Did some fraction magic, solved for x equals 80. Then I drew a handy dandy blue line, because we know lines are 180 degrees. So this whole angle here is 3x minus 2 plus y degrees is 180. Y plus 3 times x minus 2, but we know that x equals 80, equals 180. Do some math. I got y equals 122. Another one. Okay. It looks like right here I have vertical angles. See if you can make that work to your advantage. Okay, this one was a little bit easier. I have vertical angles, so if I add these two together and set it equal to this one, add these two together, set it equal to this one, I get my answer. Here I have a straight line. Those sum to equal 180 and solve for y. Second to last slide. Go ahead and push pause. Alright, check that one out. You'll see in red I made a straight line. Whoops. Straight line, so I added up everything on this side of the straight line and set it equal to 180. Okay? And then I saw in blue that these are vertical angles, so they're equal to each other. So I did 3x plus 10 equals y minus 3 plus y, plugged in what we solved for x, and solved the problem. Phew, last slide. We need to make sure that you guys are getting all of the relevant vocabulary. It's in your classwork. We just need to make sure that you're learning it and remembering it. The last thing I want to point out is a few distinctions. What is the distinction between a complementary and a supplementary angle? Complementary, remember, two angles, two or more angles that add to, just two two angles that add to 90 degrees, supplementary, they add to 180 degrees. They don't necessarily need to share a common side, but they do need to add to the correct amount. If two angles are adjacent on a straight line, what are they called? A linear pair, which are also supplementary. What is the angle sum of adjacent angles around a point? That makes a circle, which is 360 degrees. Okay, I've got a few question little quiz that I will always keep on hand if I notice you guys aren't watching videos. So you'll always need to be prepared for an entry ticket tomorrow. Good work today.